In the previous video, we talked about the two phases of writing any TensorFlow program. In the first phase, we write the code for building the computational graph. And in the second phase, we write the code for executing the graph. And we talked about three different ways for executing the graph. Right, that's sort of the first. This commented section is like the first way of executing the graph. You create a new session, and then use the session to run the initializer for your variables, and then to run the complete graph to get the results, and then close the session. Right. The second way is to use a with block. Right, with block. The with block is going to automatically close the session once you finish it. At the end of the block, basically. And then inside of the with block, you can still use the initializer to run the run method on the initializer, right? And then use the eval method on the final node of the graph. And the third way is to actually use this init node that's gonna sort of execute the global variables initializer method to replace all those individual initializations for individual variables if you have lots of variables. So we talked about three different ways for executing a session. Once we have finished building a graph, TensorFlow provides a very nice interface to display the graph in a browser. It is actually a very useful capability for identifying possible errors in the graph, and also for finding bottlenecks if you want to sort of improve the performance, so on and so on. To use this visualization capability, we need to complete two steps. In the first step, we need to add some additional code to write the graph data into a log file on the disk. And then in the second step, we need to run the TensorBoard program to display the graph. The TensorBoard program is actually included in the TensorFlow distribution, and when we installed TensorFlow, the TensorBoard is also sort of installed also. So now let's work on the first step, which is to write the graph data into a log file on the disk. And we need to use a different log directory every time we run our program. Otherwise, TensorBoard will merge data. It will merge data from different runs, and will mess up the visualization. So every time we run the program, we need to sort of create a new log directory. And the simplest solution to create a new log directory every time we run it is to actually use a timestamp, to include a timestamp in the name of the log directory. And in order to do that, we need to do another import first. So we're going to have to sort of from datetime import datetime. So we need to import the datetime object from the datetime package, the datetime module, basically. And the datetime object actually has many useful methods defined on it. So here we're going to use its called a UTC now method, which is going to return a datetime object. So we're going to define a new variable that's called a now. It's datetime.utc now, right? And this UTC now method is going to return a new datetime object, right? And this new datetime object, on this new datetime object, we can call another function, another method called strftime. So strftime. This strftime is going to convert the datetime object into a string. It's going to actually convert the datetime object into a string with some kind of a control format. And this control format we're going to use is going to look like that. This control format is basically just a string. It's just an ordinary string. The only thing that's kind of weird is this percentage sign. The percentage sign in front of capital Y, small m, small d, capital H, capital M, capital S. This sequence of string actually means, it means if it's a capital Y, it means it's a 4-digit year. If it's a small m, it means it's a 2-digit month. And then a 2-digit day of the month. And then a 2-digit hour. It's 2-digit hour. It's a 2-digit hour on a 24-hour clock actually. And then a 2-digit minute. And then a 2-digit second. So we're gonna sort of format the datetime object into this particular string with this particular format, right? So UTC now is gonna return the current time in terms of the current coordinated universal time, or UTC time. So it's a UTC time, and it also has a method that's called now. It's not UTC now, it's a now, and then the now method is going to return just the local time, but here it's a UTC time. It's a universal, it's a coordinated universal time. So this now variable is going to have a is going to be a string. And then once we have this this variable that's going to represent the time when this particular program is run, right? UTC now is going to make sure that it's going to return a datetime, UTC datetime, at the moment this particular line is being executed, basically, right? So that's going to be our timestamp. So this variable is going to be used for. So every time it's we execute this particular program, this now string is going to be different. It's going to be used to store the UTC time at the moment that this program is run. And now we can use this particular timestamp to construct our log directory. So we're going to define another string called root dir. I'm going to just gonna call it tf_logs. That's gonna be my path, the path to my log directory. And then we can construct the absolute path of the log directory using the timestamp. So I'm gonna call it log dir. Log dir equals to root log dir, and now is the timestamp. So the absolute path of the log directory is going to be this curly brackets. This pair of curly brackets are going to be replaced with the root log dir that we just defined here. Users, ProChain, Dropbox, teaching, machine learning, MACHINE, LEARNING, and then underscore and then TF_logs, right? So these curly brackets are going to be replaced with that. And then under this directory, we're going to have a directory that's called run dash. And then this pair of curly brackets are going to be replaced with a timestamp now. And now it's sort of created here. Right? So now, so this way we can actually sort of construct a timestamp to include a timestamp into our log directory. If we would like to sort of take a look at this log directory, we can just print it out and see it, just in case I made some mistakes in this piece of code. So once we have finished constructing the log directory, writing out the graph data only involves one line of code actually. So file writer equals to tf.summary. I'm actually calling the constructor of the file writer object, and then it's going to take the log dir as its first input, and then the second input is actually the graph. The graph. So here we're gonna get the default graph. We're gonna call the get default graph method. So this get default graph method will return the current default graph. So in fact, TensorFlow allows us to construct multiple computational graphs in one program. But at every instance of time, there is only one default graph. So this get default graph method will return the current default graph. And for now, we have only one graph in our program, so it's gonna return that graph. So this line is gonna create a file writer object. And this object is going to have a name that's called file_writer. Right? And this object can be used to write different kinds of data to the log files in the log directory. And then the log directory is actually the first input to the constructor, to the file writer constructor. It's just a special kind of function that allows you to actually, that's going to return a file writer object, basically. Upon creation, the file writer creates the log directory together with its parent directories if they do not exist, if they do not already exist. And then it's going to write the graph definition, the definition of this default graph, basically. And that definition is written in a certain kind of a binary format, right? And this binary log file is called an event file, actually. It's called an event file. So by now, all the codes that we have written so far, all the codes that we have added, all these codes that we have added so far, are at the very end of the graph building phase and before the graph execution phase. And during the execution of the graph, the file writer object that we define here can be used to add additional information about, for example, the training process of the neural network to the event file. But for this particular example that we're going to do today, in this particular video, we will not really add any information to the log files using the file writer object. So let's skip that step. But later on, when we sort of try to study more complicated examples, we will be using the file writer object to write out information about the progress of the training process. And finally, we must remember to close the file writer object before we actually finish the program. So we cannot sort of forget to do this file writer. So by now we have actually completed the first step for visualizing the computational graph. And we need to run this program to create the event file now. Let's just run it. So it has finished running and printed out the correct output. And now we can actually move on to the second step. And the second step is to run the TensorBoard server in the terminal and give it the log directory that we created in our TensorFlow program, which is this particular directory. Right. So first thing is to launch the terminal first. So I'm on a Mac. So the way for launching a terminal is just by holding down the command key and press the space bar and then type the name terminal inside of the Spotlight search. If you are on a Ubuntu or Linux operating system, the terminal, you also have a terminal application. You can run that application. If you are on Windows, you need to run the cmd command, the command window. So now I am actually inside the my terminal. Let me clear the window and I blow up the fonts. So if I do a listing, I should be able to see a tflogs directory. This tflogs is actually created right here, right? And underneath the tflogs there's gonna be a subdirectory that's called run dash followed by a timestamp. and all my event files are going to be stored inside of these directories. So if we do that, if we just do a listing, we're going to see that it's run dash, that's the timestamp. And inside of this log directory, we're going to see events files. Right. So now let's run TensorBoard. If you have successfully installed TensorFlow on your machine, you should be able to actually invoke TensorBoard. If you cannot find TensorBoard, you can try to locate it. Try to locate it either using some kind of a search utility, or by trying to look into the directory where you installed TensorFlow. And this TensorBoard application is going to take a command line option that's dash dash 2 dashes followed by log dir. That's the log directory. And then we need to just copy and paste this part of the string of on here. It doesn't. You don't have to sort of follow the tflogs with run dash followed by the timestamp thing. All you need to do is to give it the root directory of the log directories, and then TensorBoard is gonna automatically search for those event files underneath this particular directory, and then here we can just press enter. Now TensorBoard is gonna tell you where to look for. It's gonna give you a URL to look for the computational graph. Right, that's gonna be the URL. So that's actually the port number 6006. So 6006 actually is GOOG, sort of plotted upside down. So it's a kind of abbreviation for Google. So they use this kind of port to indicate it's a TensorBoard thing. It's a Google thing. So at this point you can just copy this URL, and then you can just open a browser. So here it's a browser. Then all I have to do is to actually copy and paste this particular URL into the browser. And now you can sort of see the graph. That's the graph. And you have to sort of keep the TensorBoard server running in order to actually get a dynamic image of the entire thing, right? And you can try to sort of move your fingers across the trackpad, and here you have a small square that allows you to actually zoom into different regions of the screen. If we want to zoom in, so here you can see the graph better, right? So let's look at if this graph is indeed what we have constructed. Let me change the window size a little bit. Right, so x is a variable, y is another variable that we have created, right? And then here f equals to x multiply y. So both x and y goes into a node that's called mul, which represents the multiplication operation. It's also a node, right? And then the result of the multiplication is added with 2, a constant 2. So that's the constant. And then the result of the multiplication and the constant both goes into a node that's called add, right? So that's indeed the graph that we were trying to construct. To reduce clutter, some parts of the graph are collapsed by default. To expand those subgraphs, we need to click on the small plus icon here. We just double click on it. If we double click on it, we get a slightly bigger view about the X node. And you can see there are lots of things that's actually going on inside of this X node. It looks like it's just a variable, right? But it actually goes through like 1, 2, 3, 3 operations. And 4. Actually goes through 4 operations, right? You have dash lines here. Let's call it init. Right, so that's the initial value. If you click on the initial value, you have a value of 3. It's a int, right? Is that what we assign to X? Yes, that's indeed what we assign to X. Right, so assign itself is actually one operation. It's an op. It's a node. Right. So both X and Y are gonna go through the init phase basically. Right. And let's look at the Y. Let's look at the Y. Double click on the plus sign. Right. So the init value for Y is going to have a value of 4 here. Right, that's the 4. And you can see 4 here. Right. And then you have a constant. So constant should have a value of 2. That's indeed 2. Right. So by now, all the nodes we have created so far are automatically added to the so-called default graph. In most cases, this is fine, but sometimes we may want to manage multiple independent graphs in one program. So to create a new graph, manage multiple graphs. So we're going to create a new graph. We're going to create a new graph in the same program. We're going to call this new graph graph 1 equals to. All we have to do is to create a new graph is call the graph method. Right? It's a constructor. So basically, it's a with no input. With no input, then it's going to create a graph for us, and we can call this graph 1. And for now, graph 1 doesn't have any nodes yet. And to add new nodes to this new graph 1, we need to temporarily make graph 1 the default graph. And we can do that within a with block. So with graph 1 dot as default. So here we are calling the as default method defined on a graph, defined on graph 1. And by calling this particular method, we're going to convert graph 1 into the default graph inside of this with block. Inside of this with block. And inside of this with block, graph 1 is going to be the default graph, right? And now we can add new nodes into it. So let's add x1. x1 is going to be a TF variable. And we're going to assign values 3 to it. And then the name is going to be x1. Let's just call it x1. And then we do y1 equals to TF dot variable. Let's still give it a 4. And then name equals to y1. Right. And then we're going to define f1. f1 is going to equal to, this time we're going to use x1 plus xy1. Instead of x multiply y, we're going to do x1 plus y1. And then instead of adding the constant 2, we're going to do a multiplication of 2. So the computational graph is supposed to be different from this one. The computational graph we build here, right? So let me write one more comment. Building graph 1, first phase. Right, that's trying to build graph 1. So this as default method will automatically convert graph 1 into the default graph inside of this with block. And inside of this width block, we have added 3 nodes to graph 1. Right. Once we are sort of finished with this particular width block, we can go outside of it. Right. So now graph 1 is not the default graph anymore. So outside of this width block, graph 1 is no longer the default graph. And we can actually check that by comparing the graph object associated with the x1 variable with the default graph. So we're gonna do a check x1.graph. So x1 is a variable, right? And every variable is gonna have a member inside of it. It's actually an object. By calling .graph, I'm gonna get a handle to the graph that x1 is associated with, right? And we can compare that graph with the default graph outside of this width block, and I can just get the default graph by calling the get default graph function on the TF package, right? And it's supposed to return a false. Basically, it's gonna return a false, and then I'm gonna do another comparison, and this is supposed to be false, and this is supposed to be true, right? So after we have finished constructing graph 1, so here the building phase, the first phase has finished. After we have finished building graph 1, we can try to create a new log directory for storing event files of this new graph. So we can do root log dir1 equals to root log dir plus 1. So basically what we are going to do is to just append root log dir that we have already constructed at the beginning here with a number 1 here. We're just going to append 1 behind this thing, behind this string. So the new root log dir is just going to be tf underscore logs with a 1 behind it, right? That's going to be our log directory for graph 1, for this particular graph. And then log dir1 equals to format log dir1, and then now that's the timestamp, right? And then we'll define another file writer. We're gonna call file writer 1 equals to tf.summary dot file writer log dir1. It's not log dir anymore, right? It's log dir1. The log directory we just created. And then the second input is supposed to be the graph, right? And here we have used when we actually did the first file writer, we actually used the default graph as the input, right? But now we are not going to use the default graph. We're going to use the graph 1 as the second input. So this way it's going to create a file writer that's associated with this particular log directory, log dir1, and also this graph 1. It's not the default graph here, right? So basically that's the construction phase. Executing graph 1, second phase. So now let's try to execute graph 1, right? So in order to actually execute graph 1, we need to open a new session. So here, this session has ended already, right? So this session is associated with, is inside of this particular width block. When this width block is finished, this particular session is automatically closed by this width block. So there's no session, there's no active session now. So we need to create a new session. When we actually launched this particular session, there's no input to it, right? There's no input to the constructor. And if there's no input, then this session is going to be used to run the default graph. But here we are actually trying to launch a session that's going to execute a graph that's not the default graph, right? Because this is outside of this width block, right? If it's outside of this width block, then graph 1 is not the default graph. If it's not the default graph, we need to create our session in a slightly different way. Session graph equals to graph 1 as. So here we need to pass the constructor a input variable that's graph equals to graph 1. And if we actually do that, then the newly created session called SESS is going to be used to execute graph 1 instead of the default graph. And we can do the similar thing. x1 dot initializer dot run, y1 dot initializer dot run, and then result 1 equals to f1 dot eval. So here the most important thing to remember is that this session constructor has an optional input for specifying the graph you want this session to execute on. And without this input, the created session will be used to execute the default graph only. Right. And now we have finished executing our graph 1. And now we can actually just print out the result. Result 1 is supposed to be 14 also, right? So 3 plus 4, that's 7. 7 multiplied 2, that's 14. Right? The result should be exactly the same as the result here, right? The result here is 3 multiplied 4, that's 12. 12 plus 2, that's 14, right? So both results should be 14. And then don't forget to close the file writer. And by now we have sort of finished writing the execution phase of graph 1. And if we run this program now, it's going to create 2 log directories with 2 sets of event files in those 2 log directories respectively. And if we want to examine these 2 graphs, we can sort of run TensorBoard again. But before I run this particular piece of code, let me clean up my log directory first. So here I'm going to press Ctrl+C to stop the TensorBoard. And then I'm going to just I'm just going to delete my log directories. Do I have a... No, I have no other log directories now. Let me just run this program and it's hopeful I didn't make any mistakes. Yes, it's a 14 and then another 14. And it's false and then true, right? So this false is coming from this print. This print is actually printing out the result of this comparison. So basically we are comparing the graph that's associated with the variable x1 with the default graph that's outside of this width block. So it's going to return false. It's not the default graph anymore. And then this is comparing the graph that's associated with the x1 variable with graph 1. Right? We know that x1 is defined on graph 1. It's a node on graph 1. Right? So this is supposed to be true. This is supposed to be true. Right? So now we have created 2 log files, tslogs and then tslogs1. Right? And then let's just run TensorBoard. Is a log dir given by So where am I? So if that's the case, I don't have to type everything that's in the front. I can just do a TF logs. That's supposed to be the original. That's supposed to be the default graph, right? It's supposed to be the default graph. Basically, all I have to do is to reload it. Basically. For some reason, the default graph was executed like twice, so you get like two things, two graphs. For some reason, if I stop it and then give it another one, this time I'm giving it tf underscore logs 1, right? It's supposed to be used. It's supposed to be the graph for for graph 1. So, oh, I'm not supposed to do that. Let me just zoom in this way, so I can show you the difference between these two graphs. Let me just drag apart these two browsers. That's actually two different graphs, right? So that's x and y. Both of them actually goes into the multiplication node. And the result of the multiplication, together with the constant, goes into the add node. But here it's x1 and y1 variable goes into a node that's called add. So we're going to add x1 and y1 together. And the result of the summation, together with this constant, goes into a multiplication node. Right? So here it's add and multiplication. Here it's multiplication and add. Right? They are two completely different graphs. And this is for graph 1, right? Graph 1. In graph 1, what we did was multiplication, to do the addition first, and then multiplication with 2, right? The addition first of x1 and y1, and then do the multiplication. And then in the default graph, what we did was x multiply y, and then add with 2. X multiply with y, and then add with 2, right? So that's gonna give you two different graphs.